Islands aren't supposed to move. We think of them as permanent, solid anchors of rock and soil in our oceans and lakes. You can map them, visit them, even live on them. They're fixtures of our world, unmoving and unchanging. But what if there was a place where islands were just illusions? Fleeting ghosts that appear in a vast sea, only to vanish without a trace. This isn't a fantasy novel. It's a real mystery unfolding hundreds of millions of miles away, on Saturn's largest moon, Titan. For years, scientists have been watching so-called magic islands appear and disappear in its frigid seas, and the explanation is more alien than we could have ever imagined. It's a phenomenon that forces us to reconsider what an island can even be. The story of floating islands starts right here on Earth, but it leads us to one of the greatest enigmas in the outer solar system. Before we jet off to the bizarre seas of Titan, let's start with something a little closer to home. Here on Earth, floating islands are very real, but they aren't magic, they're alive. You can find them in lakes and rivers all over the globe, but they aren't islands in the traditional sense. They are floating masses of vegetation, dirt, and organic gunk that have either broken off from the shore or bubbled up from the lake bed. In South America, they're called camalotes, massive rafts of water hyacinths that drift down the Rio Paraná. In India's Loktak Lake, they're known as fungus spongy, circular landmasses that locals actually build huts on for fishing. And in Uganda, communities have long relied on the vast floating islands of Lake Kyoga. The way these form is a pretty incredible display of nature's ingenuity. It usually starts with the dense, tangled roots of water plants like reeds or papyrus. Over time, these roots trap mud and decaying plants, creating a thick, buoyant mat. This mat can get so sturdy that it doesn't just support more plants, it supports entire ecosystems. The roots that dangle underneath become a perfect nursery for fish, while the island's surface is a safe haven for birds to nest, far from predators on the mainland. These natural islands are crucial for their environment. They work like giant, mobile water filters, with their roots soaking up extra nutrients and pollutants, which cleans the water. They also adapt to changing water levels by just rising and falling with them. Inspired by this, scientists have started making their own versions, constructed floating wetlands. These man-made islands, often built on sustainable frames, are placed in urban lakes and polluted waterways to help clean them up. They do the same job as the natural ones, providing habitats, filtering water, and bringing a bit of wild, moving nature back into our concrete jungles. So, on Earth, a floating island is a marvel of biology. But what happens when you try to make an island float on a world with no life as we know it? What happens on Titan? Titan is one of the most Earth-like worlds we've ever found. But it's an Earth seen through a funhouse mirror. It's bigger than the planet Mercury and is the only moon in our solar system with a thick atmosphere. Like Earth, it has weather with clouds, rain, rivers, lakes, and seas. But on Titan, where it's a mind-numbing negative 290 degrees Fahrenheit, this whole cycle isn't based on water, but on liquid methane and ethane. Methane falls from the sky like rain, carves rivers into the frozen ground, and pools in huge dark seas. For 13 years, NASA's Cassini spacecraft stared at this strange cold world, using radar to see through its thick orange haze. Then, in 2014, Cassini saw something that shouldn't be possible. In Ligeia Mare, one of Titan's biggest seas, a bright feature suddenly appeared where there had only been dark, open liquid. Scientists had found a new island, but when Cassini flew by again, it was gone. Then it reappeared, but it looked different, and then it vanished again. They nicknamed them Magic Islands. And these weren't small specks. Some were tens of miles across. They would flicker in and out of sight, sometimes for hours, sometimes for weeks, before disappearing completely. Scientists were stumped. On a world as frozen and geologically slow as Titan, how could giant landmasses just pop in and out of existence? This wasn't like the living islands of Earth. This was an alien puzzle. So, what was going on? The first challenge for scientists was figuring out what could possibly be temporary in a sea of liquid hydrocarbons. The initial ideas were logical, but each one hit a wall. One of the first thoughts was waves. Maybe wind was kicking up the surface of Ligea Mare, creating huge waves that Cassini's radar would see as a bright spot, looking like an island. The problem? Titan's seas are bizarrely calm. The moon's dense atmosphere and weak gravity mean that even if there is wind, the waves are probably only a few centimeters high. It just didn't seem likely that tiny waves could create something that looked so big and solid. The next idea was bubbles. Scientists theorized that as the seafloor warmed or the atmospheric pressure changed, dissolved nitrogen could fizz out of the liquid methane, kind of like a can of soda. A giant field of bubbles rising to the surface would be super reflective to radar, creating the illusion of an island. This was a pretty good theory. It explained why the islands were temporary. Once the bubbling stopped, the island would disappear. But this idea had problems too. What could cause such a massive, synchronized release of gas over such a huge area? And could the bubbles really stick around for weeks at a time? The bubble theory was a solid contender, but it didn't feel like the whole story. After wrestling with waves and bubbles for years, a new, more elegant explanation emerged in early 2024, and it has become the leading theory. The idea is that the magic islands are neither waves nor fizz, but something much more familiar yet totally alien: floating solids. Titan's thick, hazy atmosphere is like a giant chemical factory. Sunlight and radiation break down methane gas, creating all sorts of complex organic gunk. These compounds clump together, freeze, and slowly rain down on the surface. Over millions of years, this stuff has built up, forming Titan's vast fields of dunes. The new theory, from planetary scientist Xinting Yu and her team, asks what happens when this organic material lands in the methane seas. The main problem was always density. Most of this frozen organic stuff is denser than liquid methane, so it should sink. To float, you either need to be less dense than the liquid, or you need to be porous. And that was the breakthrough. The researchers suggested that these solids don't just sink like rocks. Instead, they build up along the shorelines, forming large, porous clumps. Imagine something like sea foam or slushy ice collecting on a beach. Eventually, these massive clumps could break off from the shore, like a glacier carving into the ocean, and drift out to sea. According to their models, if these floating chunks are porous enough, full of holes and channels like a pumice stone or a block of Swiss cheese, they would be buoyant enough to float. The liquid methane would slowly seep into the pores, but if the chunk is big enough, it could stay afloat for days or even weeks before it gets totally waterlogged and sinks. This one theory explains everything. It explains why the islands appear. A huge porous iceberg of organic material breaks off the coast and floats into view. It explains why they disappear. They eventually get saturated with methane and sink to the bottom. And it explains why they change shape. The berg might partially crumble or rotate as it drifts. The magic islands, it seems, aren't magic at all. They are Titan's version of icebergs, not made of water ice, but of frozen, porous, organic solids, drifting on a sea of liquid methane. It's discoveries like this that are the perfect example of why we explore. Every puzzle we solve on a world like Titan gives us a deeper understanding of how planets work, including our own. If you think these cosmic mysteries are as fascinating as we do, make sure to like this video and subscribe for more journeys into the unknown. The story of floating islands takes us from the familiar to the fantastically strange. On Earth, they're living, breathing platforms that build entire ecosystems. On Titan, the magic islands are likely massive, porous bergs of frozen organic chemicals, breaking off from the shore and sailing silently on seas of liquid methane before sinking into the dark. The Cassini mission, which first spotted these islands, ended its journey in 2017 with a final, fiery plunge into Saturn's atmosphere. But our exploration of Titan is far from over. NASA plans to launch the Dragonfly mission in July 2028, a nuclear-powered quadcopter the size of a car, designed to fly through Titan's thick air. Scheduled to arrive in 2034, Dragonfly will hop from place to place, sampling the surface and studying the very materials that might be forming these magic islands. What other secrets are hiding under Titan's haze and in its dark seas? Solving the mystery of the magic islands has just opened the door to even bigger questions. We've gone from seeing islands as permanent fixtures to understanding them as dynamic, temporary features, born from both biology and bizarre alien chemistry. And with missions like Dragonfly on the horizon, we're on the verge of uncovering even more wonders in this strange, yet strangely familiar, corner of our solar system.